The next place you'll be asked to identify slope or rate of change and starting point or y-intercept is from a function rule or from an equation. This is actually relatively simple if your equation is in function form. When directions say to put something into function form, it's asking you to solve for y. So understand function form means solve for y. In these first two examples, they are both in function form. So the other way that you'll see function form is f of x. Remember, that is a substitute for y. So this one is solved for y and this one is solved for y. What you notice on your homework from a week or two ago was that when we were finding rate of change from a table, it always matched up identically with the number that you were multiplying x by. That is always the case as long as your equation is in function form. So with our first two examples here, the equations are in function form. So we can identify our slope and our starting point from this function form. The slope, or your rate of change, will always be the number you're multiplying x by. In this first example, that's 1/2. In your second example, your slope is -5. That's the number you're multiplying x by. Your starting point, or your y-intercept, is always the constant at the end of your function rule, including the sign in front. Because this is subtracting 9, your starting point is -9. That is the y coordinate. What's your x coordinate every time for a starting point or for a y-intercept? That's right, it's 0. Hopefully you said 0. 0, -9 would be your starting point for this first example. The second example, your starting point, again 0 for your x. In this case you're adding 12. That's your constant in your function rule, so it's 0, 12. In these next two examples, they want us to solve for y first, put the equation into function form. From there, we can identify the rate of change, or the slope, and the starting point, or the y-intercept. But we cannot do that until we solve for y. This is why we had the section during our solving unit where we had spent so much time solving for y, literal equations. So a quick review of that. If this is my equal sign, I want at the end this to look like y equals something. So here's where my y is. It's a -6y. I have to move my x term first if the x term is on the same side. Positive 4x means I'm going to subtract 4x from both sides. It goes away on the left-hand side. It leaves me with -6y on the left. On the right, these are not like terms. You could write this as 18 minus 4x. In the future, we're going to talk about why we want to write that x term first. But for right now, let's just stick with whatever's on top gets written first, whatever you're adding or subtracting gets written second. Your equal sign gets brought straight down. Last step here would be to move the -6. So I'm going to divide every single term by -6. That leaves my y alone on the left. Now I simplify fractions. 18 divided by -6 is -3. This is a -4 divided by 6. Negative divided by a positive will be a negative, so I'm going to subtract. Now it's a fraction I need to simplify. 4 over 6 simplifies to 2 over 3, x. I am now in function form. I've solved for y, so I look for my rate of change. Remember, rate of change and slope are always with x. It's the number you're multiplying x by. In this case, my x is here. I'm multiplying it not by 2/3, but by negative 2/3. That gives me a rate of change of negative 2/3. And then my starting point is the number in front, this case. It's your constant, the term that's not with x. And so it's -3, but it's not just -3. It's an ordered pair, 0, -3. I want you guys to try part B on your own. I'm going to give you a hint, and that is that your starting point will be 0 something. You can always do that. When I ask for the starting point or for the y-intercept, you can always go ahead and start it by 0, something. That's what you're looking for when you're finding a starting point or a rate of change, or a y-intercept, excuse me. Go ahead and press pause and try B. So, function form, y equals 30 minus 9x, which means your rate of change in this case is -9. That's what you're multiplying x by. And your starting point is 0, 30. That's your constant term here. The last problem for today, rate of change or slope from a word problem. You will be asked at times to come up with a rate of change given a word problem. Oftentimes in the directions it'll tell you to write 2 ordered pairs. In this case, we can come up with 2 ordered pairs from this word problem. It says that in 2 weeks, Bob went through 196 diapers at home for his twins. After 5 weeks, he went through 490 diapers. What is the rate of change? And what does it mean in the context of this situation? We can come up with 2 ordered pairs from the information. Keep in mind, when you're setting up your ordered pairs, your x coordinate should always be first, but also if you have anything that has to do with time in your word problem, seconds, minutes, hours, days, weeks, months, years, anything that has to do with time, that's going to be your x, or your independent variable. So in this case, we have 2 weeks and we have 5 weeks. Those should be your 2 x coordinates, 2 and 5. And you have to match those up with the other numbers. 196 diapers is matched up with 2 weeks, so 2 and 196. 490 diapers is matched with 5 weeks, so 5, 490. Once you have written your ordered pairs, it becomes a problem like from earlier in the notes where we're finding our jumps. What does it take to get from 196 to 490? What does it take to get from 2 to 5? Go ahead, hit pause, calculate this, and see if you can write a sentence that explains what it means in the context of this problem. So we find a rate of change of 294/3. Don't forget, that can always be simplified. So when I simplify 294/3, I get a rate of change of 98. The 294 represent your change in diapers, so it's 98 diapers. The 3 represented your change in weeks, so it's per week. And if you think that's a joke, think about what I'm doing right now. That's about correct. So, in the context of this situation, it means Bob is changing, and you can always replace Bob with Mr. Szabo, 98 diapers per week. Okay, you'll have some time to work on your homework now. Please work on it individually. Don't work on it in groups. If you have a phone, you can go ahead and scan these notes videos again and re-watch them so you can take a look at them and help you with your homework. If you don't have a phone, they will be posted on my website, so you can check all the videos out again when you get home online.